Hello everyone, my name is Sethi. I hope you all are staying healthy. Today we are going to talk about how to find out maxima and minima through derivative. As we know, finding maxima and minima are important part of optimization problem. Producer want maximum profit and minimum cost, but how we can find maximum profit output and minimum cost output? In economics, we use derivative in order to find out maximum profit output and minimum cost output. For example, we want to find out maximum profit output through optimization. We need to follow these three steps. In first step, we calculate first order derivative of profit function. In second step, we set first order derivative equal to 0 and find out critical point. In third step, we calculate second order derivative. If second order derivative is less than 0, for example, second order derivative is in negative, it shows maximum profit output. Now suppose we want to find out minimum cost output through optimization, then we need to follow these same three steps. In first step, we calculate first order derivative of cost function, then set this first order derivative equal to 0 and find critical point. In third step, we calculate second order derivative. Now please listen carefully. If in case of cost function, second order derivative is more than 0, for example, second order derivative is plus 2, it shows minimum cost output. In case of profit function, if second order derivative is less than 0, it shows maximum profit output. But in case of cost function, if second order derivative is more than 0, it shows minimum cost output. Now we will see one example how to find profit maximization in optimization problem. This is our given profit function. In first step, we will calculate first order derivative. We already know how to calculate derivative. First of all, we will calculate first order derivative of given profit function. Derivative of 100 is 0, means derivative of constant is 0. Derivative of 160q is equal to 160. Derivative of 10q square is equal to 20q. So this will be called our first order derivative. In second step, we will put first order derivative equal to 0 and find out value of q, or you can say that find out critical value. Value of q is equal to 8 unit. Now we will see, are we receiving maximum profit at this 8 unit of output or not? In order to know maximum profit point, we will do second order derivative of this first order derivative. Now we will take second order derivative for this first order derivative function. So derivative of 160 is 0, derivative of minus 20q is equal to minus 20. We have already discussed, in case of profit function, if second order derivative is less than 0, that means we are receiving maximum profit. Minus 20 is less than 0, that means we are receiving maximum profit at 8 unit of output. Now in this original profit function, in place of q, we will put 8. So when we put 8 in place of q and solve, our answer become equal to 540. That means our maximum profit is 540 at 8 unit of output. Now we will see one more problem. This is our given cost function. We have to find out number of items that minimize our cost. In first step, we will take first order derivative of given cost function. Derivative of x square is equal to 2x. Derivative of 160x is equal to 160. Derivative of 7500 is equal to 0. So this is our first order derivative of given cost function. In second step, we will put first order derivative equal to 0 and find out critical value, or you can say that find out value of x. Value of x is equal to 80. Now we need to see, are we achieving minimum cost at this 80 unit of output or not? In order to know this, we will do second order derivative of this first order derivative function. If second order derivative is more than 0, that means we are receiving minimum cost, we are achieving minimum cost. If second order derivative is less than 0, that means our cost is maximum. As we already discussed, less than 0 shows maximum function. So we will take second order derivative of this first order derivative. Derivative of 2x is equal to 2, derivative of 160 is 0. So our second order derivative is 2. 2 is positive and more than 0. That means 80 unit of output, giving us a minimum cost, or you can say that we are able to achieve minimum cost at this 80 unit of output. Now in place of x we will put 80 unit. So in place of x we put 80 unit and solve this, it will become equal to 1100. That means at 80 unit our minimum cost is 1100, or you can say that in order to achieve minimum cost output, a firm should produce 80 unit. So this is all about today's video. I think you got it, and thank you so much for watching this video. Bye, take care.